today and go over some of the symbols that we've had so far. The standard deviation is going to be 3.2 in your notes. And again, you're going to be highlighting. We're going to get into a table today, which the table should be in your notes as well as we go through it. You're going to add the table. The table is not in your notes. So when we go through the table, hopefully you're going to be writing that down. Standard deviation. So far what we've talked about is the mean, median, and mode. The mean had two symbols. And let's say that we have a sample and a population. And the sample is a subset of the population. We know that the mean value is going to be X bar. It's called X bar. And that's going to be the mean. And that can go both ways here. And for the population mean, that is going to be the symbol mu. And the calculation of those means are exactly the same. There's nothing different with that. However, we are going to get into something called a variance. And a variance is going to be labeled differently for one or the other. For the sample variance, it's going to be labeled as S squared. And for the population variance, it's going to be little sigma squared. So this is just S squared. This is little sigma is the name of that symbol. A sigma symbol is an uppercase is this, but this one is going to be lowercase, just like we have capital letters and lowercase letters. This would be like our capital, and this would be like our lowercase. So when I say little sigma, we're talking about that symbol right there. And the way that you need to calculate the variance is different for the sample or the population. And for the sample, the way that you're going to calculate it is going to be where you take the sum, that's the big sigma, of x minus x bar quantity squared and divide it by your n minus 1. N is the total number of data points. And then on this population variance, it's going to be where you sum up all the deviations, let's call them, between x and mu. Notice that I'm talking about mu here, and I'm going to divide that by n, which is the total number of points. Yes, there is a difference in the denominator here. The sample, when you're trying to find the variance for a sample, you need to account for the difference between what it really represents, because if you looked at a population, you'd have all the numbers, and when you did this, you'd get the actual standard deviation. But through trials, they found the sample variance to be more representative if you divide by n minus 1 to account for the fact that you're not talking about all the data points. You're talking about a sample of them. So you need to know the difference between those two. Now, the next one is going to be the standard deviation. And the standard deviation in both cases is just going to be the square root of the variance. So you're going to take whatever this is and take the square root of it. So I can just label this as s, because if this is s squared, taking the square root, you're going to get s. as well as little sigma. This is just going to be little sigma. This is little sigma squared. You take the square root of it, and you get little sigma. So there's a difference between sample and population. It's sometimes not real clear if you're talking about a sample or population. All right. On the test, I will be clear to tell you that this is a sample, and then you need to know, go on the left side. Or this is all of the numbers, therefore you're going to go on the right side. All right. So let's, for example, say that we have a problem that we're going to do, and the problem is going to require us to figure out how many extracurricular activities we're in. So I want you to think to yourself about extracurricular activities, and then we'll make a list. We'll generate a list on how to do this. All right, great. So let's see. We're going to have some extracurricular activities. They could be in music, sports, religion, work, sports, if I didn't say it, place. So get a number and then tell me, please, the number that you have, starting here and going back.
Me? 8.
All right, so we have quite one more, please. We have quite a variety of numbers here. The total number of data points is going to be, let's see, 13 probably. So we're going to remember that 13 is the total number of points. Right. 14 is the number of data points instead of 13. So this is going to say, let's be a sample, a decent sample, and we'll get later in the book, will indicate what makes a good sample. But let's just say, for all practical purposes, this is a good sample, and it represents the whole population in North. So we have 14, and we want to see how much these numbers vary, how much do they stray from the mean number of this data set. And then when we get into further future chapters, you're going to see that the standard deviation is a big part of what we're going to be computing with statistics. So standard deviation is going to be something that comes up over and over again. All right, so I want to do this first by hand with a table, and then I want to go to my graphing calculator. How do I do this at the table? Well, first of all, what I want to do is create an X, and I just want to do my table in terms of following what the formula is for finding the standard deviation. So it's x minus x bar, x minus x bar quantity squared. And when I do this and get an answer, I want to get whatever number that is, and I want to, this is going to be the sum of that column, because what I'm really calculating here is going to be the sum of x minus x bar squared. That's what I should write down here. Sum of x minus x bar quantity squared. That's what this represents. But then what I have to do is I have to take that number and divide it by n minus 1. So then it's going to be s squared equals this. And then what I want to do is I want to calculate the square root of that to get my standard deviation. So that's going to be the process that we're going to actually do. Okay? Create a table, get the sum, and then I'm going to take the sum and divide it by n minus 1, and then take the square root. Okay, these are just kind of little notes as I go through this process. So when I do this, if I were to do it by hand, I would probably put these in order because there's only 14 points, and I could do that along the way. So just going from high to low, I've got a 1, I've got a 3, and then a 2, a 3, a 4. Oops, 2 3s. Right. So 1, 2, 2 3s, a 4, a 5, 3 6s, and looks like a 7 and an 8. And 16, 20, and 34. You always want to check, are this number the same as what my total is? So I have, let's see, 3, 6, 9, 12, 14, which is nice. So, so next what I want to do is actually calculate my mean of the data by adding up all those numbers and dividing it by 14. And so I'm just going to do this off to the side here and do it quickly. So then I'm going to get my answer. And so then I'm going to see that I have 1 minus my mean. And when I get that mean, you're going to have approximately 8.64. 8.64. And then it's going to be 2 minus 8.64 and 3 minus 8.64, and that's an approximate. And then what I'm going to be doing is squaring those, 1 minus 8.64 quantity squared. And I'm going to do this all the way down. You could see by hand that's going to be a huge hassle as you go through it. Now, if these numbers were a lot easier, whole numbers, it would be definitely doable. Like if there were 5, 6, 7, and 8, and the mean was easy, that you could figure that out. But they're not. So that's why when we do this third column, I'm going to actually find the sum of this, and then again, divide by n minus 1, take the square root, and that's going to be my standard deviation. Now, I want to do this by graphing calculator now. And on the test, what I'm going to have you do is show this table and how you calculated the standard deviation. You have to know this formula for the variance and how to get the standard deviation. All right, I want you to show the table, and we're calculating the variances. So what I want to do is go ahead and get my calculator out, and when I get my calculator, I'm going to go to Stat, and I want to clear out all my lists when I do this. Now, when you clear, you go up to the L1, hit Enter, and then hit the Clear button, and then it'll clear it out. Don't hit the Delete button, because sometimes it'll delete the whole column. And then I'll do the same thing to some of these. And after I'm done with that, I'm going to now want to enter all my data points, 14 of them. So let's say I just do the original ones. I don't want to put them in order because I know the calculator can put them in order for me. So I just want to type in all of those data points as you go along. Now, when you're doing this, at the end, you're going to want to make sure you double check your numbers and see if there's anything funny looking in there. And also see if you finish up on 14. So when I go up to that 3, you can see L sub 1 is at 14. I know I entered all 14 data points. And I'm going to skim through here and make sure I see something. Oh, there's that 34 again. And so I'm looking pretty good. Now, the first thing that I want to do is go to L2 and replicate my L1. This is my original set. I don't want to mess with it. I want to keep it the way it is. So I hit enter, and I'm going to put in L2 equals L1. So second 1 tells me that that is now going to be replicated. Again, go up to L2, hit enter, and then L1, and it copies it over. Then what I want to do is go to the third list, and I want to actually take my L2, well, let's go to L2 and sort L2 so it puts it in numerical order. To do that, you quit out of the whole thing, and then you're going to go to Stat, Sort Ascending, and I want to do L2 here, so I'm going to do second 2, and that's going to give me done. So when I go back to the stat, you're going to see that that's going to be all sorted in numerical order. Then what I want in L3 is to take my L2 and subtract off the mean. L2 and subtract off the mean. So I have to figure out what is the mean of L2. I'm going to quit out of there. And to do this, I'm going to do second stat, which is list, and go to math, and you're going to see that you have a mean button in there. Go ahead and use that mean button now that we know what it is. Not median, but mean. And I'm going to go to L2. When you do that, you're going to see that that mean is going to be 8.64. Now pay attention, because if you fall behind, you're taking somebody else off with you at this point. So I now know that the mean is L2, and when you have L2, I want that to be exact as possible. So this is an important point. You want to store that number in a letter, so you can use the letter which is going to be exactly that. So I want to store, that's the STO button next to the on. So I just hit that store button, and I'm going to store the number in for a letter, which is alpha math. I'm going to store it in A. And so when I do that, my A now is that complete number. All right, so I now have my mean, which is in my A, and I'm going to use that back in my table. Stat edit, go back to L3, again, up on that L3, hit enter, and what do I want to do? I want to take my L2 minus the mean, minus A. So that's exactly what I'm going to type in here. L2 minus, and then I go back and get that letter, greeny math, which is A, and when you do that, it's going to give you the deviations from the mean. Some are negative, some are positive. In fact, if you added up this column, all those numbers in that column, you're going to end up with 0, because it's how far all the numbers are away from the mean. Some are negative, some are positive. It's going to add up. But we don't want that to be 0. That's why we have to square it. And that's what this part is. So L4 means I want to square L3. So I'm going to go ahead and do that. Enter. L3, second, 3, squared, enter, and now they're all positive. All right, so far I've gone through and I've done this part, this list right here of that equation. Now what I have to do is sum it up and then divide by n minus 1. So let's go ahead and do that on here. And you can see how important that calculator is in keeping these numbers straight. If you had to do this by hand, it'd be not so pleasant. I want to sum it, so I'm going to go to the quit, and then I want to sum, so it's going to be second stat, math, sum. Second stat, math, sum, just where that mean was, enter, and I'm going to sum up that list, and I believe it was L4, which was my last list that I have. And when I sum that, I get this number. That takes me through the summation of it, and now I have to divide by my n minus 1, so I'm just going to divide. 14 was my n minus 1 is 13. That gives me my average standard. It's like my average variance, how much it varied from the mean, my average variance, but it's squared, remember. So for the standard deviation, I want that number to reflect the numbers I'm working with instead of the squared number. So that's why you actually have to take the square root at the end. Because right now I'm dealing with squared numbers. So when I take the square root, that means it's going to be the square root of the answer. Answer is the negative. So it's going to be second negative button. I'm not approximating anywhere in the problem. My mean's not approximated. None of my numbers are approximated. Even at the end here, I'm still using the answer in the calculator. And at this point, it's going to be 8.99 is going to be your magic number, which is going to be S equals 8.99. Meaning, the standard deviation of the list of 14 numbers is going to be 8.99. 8.99 means that there's going to be 8.99 distance away from the mean is going to be your typical standard deviation with all of those numbers. Now, what that really means in future chapters is when you have your mean, if you go 8.99 above it and 8.99 below it, 68% of the numbers of these numbers are going to be within that range. And then there's another percentage you go out, another standard deviation, another percentage go out, another standard deviation. So that's where we're headed down the road with standard deviation. Okay, so by the end of the day, you should be able to know all of the symbols involving standard deviation, sample, and population. And you should be able to calculate this by your calculator, but showing the columns as you go through it. And you will need to know how to do that for the test. Test will be on Tuesday for standard deviation. Make sure you know this and know it well.